remember. So typically elimination is usually used if your equations are in standard form. So if you have your ax plus by equals c, where your a and b are on this, or your x and y terms are on the same side of the equation, typically elimination, it doesn't have to be, but it tends to be a little bit quicker to use elimination if your equations are presented to you in that format, or both of them are presented in that format. Does anybody know kind of the process for what you would actually do with the equations?
You would try to get x or y, so it's the same number, and you can just cross it out. And then you just...
Exactly. Okay, so how am I going to write this? Okay, it doesn't matter which variable, x or y, and here's my little recommendation. Have opposite coefficients. And what I mean by that, I'll just make something up. Like, let's say I had 3x in one equation and negative 3x in the other equation. So the number in front of the term, same number, but one's positive and one's negative, and then you just add the lines together. When you do that, that'll eliminate, which is what we call it elimination, that variable. Because if I do 3 minus 3, that adds up to 0, cancels it out, just as a little example. So I always tell people try to do opposites, because I've had people try to subtract one line for the other, and they always mess that up. So I just try to say, okay, if we have to run a negative through, we have to run a negative through, but you want to make the coefficients opposite. So what I mean by that, if I look at this example, like right under here, I see both of the x's are the same. Both of them are 4x. All right, all I would tell you to do, I'm just going to run a -1 through that first equation. That's all I'm going to do. Everybody on both sides gets multiplied by -1, and I'll just write it over here to the side. So it'd be -4x minus y. 0 would stay 0 no matter what you multiply it by, and I'm going to copy the second line just underneath. And I find that people make less mistakes if you have opposite coefficients, because then we're just going to add the bottom line to the top line here. So when I add 4 and -4, eliminates it, goes away. 0 is what that would add up to. -1y plus 2y would be 1y, and then 0 plus 20 would actually be 20. Now, whenever you're using substitution, it's maybe like one equation might be easier than the other. Elimination, it's usually just, it's kind of whatever your choice is, but it usually takes like a couple more seconds to go ahead and find the other variable, because it's usually both equations in standard form. You can plug that 20 in, either one in the original equation, or you can plug it into something that you may have manipulated for your purposes to do elimination. I'm just going to go ahead. Let me just use that second equation because I didn't manipulate that at all. Just make sure you plug whatever you got in for the correct variable. So we got y was 20. So I'm going to do 4x, this would be plus 40 equals 20. I'm going to subtract 40 from both sides, but I wrote too big, so forgive. If I take 20 minus 40, it's -20. And if I divide -20 by 4, which is what I'm going to do there, I'm going to get, whoops, -5. If you have to write the answer as an ordered pair, the x coordinate goes first and the y coordinate goes second. That would be the point that those two lines would run into each other on a graph. Okay, let's see. So if I wanted to use elimination on this second system, I got -2x plus 15y equals -32, and I've got 7x plus 5y equals -17. I don't have opposite coefficients on either variable. Does anybody raise your hand and tell me, like, what would you do to maybe create something so we could eliminate a variable? Okay, why? Perfect. Okay, I'm going to just do like a little add to that. You're not multiplying 2 by anything to get 7, so I wouldn't mess around with the x's, but I can multiply 5 by 3 to get 15. Just please, for me, I just recommend just run it through as a -3, because then you can add the bottom line to the top line. So I'm just going to copy the top line. The -2x plus 15y equals -32. Now I'm going to run a -3 through everybody in that second line. So negative times a negative will make this positive here, 21x. -3 times 5 is -15y. Then my y's have opposite coefficients and we can cross them out. And then -3 times -17 is 51. Bless your heart. I thought that was it, but I wasn't sure. Okay, gone. Now, what do we got? -2 and 21 would be 19x. And, oh, magical, -32 plus 51 is 19. So x is just going to be 1. Now, again, you can plug that into either one of the equations in the original system, or you can plug it into anything that you created. My recommendation here, I guess, I would use maybe the second equation just because the numbers are smaller, but it's totally up to you. So I have -7, I have x is 1, so make sure you plug it in for the correct variable. Plus 5y equals -17. So I got -7 plus 5y is -17. I'm going to just add the 7 real quick. So I get 5y equals -10. And then we'll just divide by 5 and be done. So y should be -2. And again, if you guys have to write it as an ordered pair, just the x coordinate comes first, so 1, and the y coordinate comes second, -2. If we were to graph those two lines in the coordinate plane, that's where they would intersect. Is anybody having a question? Okay. Now, both of those are equation or systems where the two lines intersect in the coordinate plane. So these are going to be a little bit trickier. I'm not multiplying here 2 by anything to turn it into 3, and I'm not multiplying 4 by anything to turn it into 5. So if you run into a situation like that, what do you guys know how to go about creating something where we could eliminate a variable? Oh, go ahead, what did you say?
Multiply both.
Multiply both. Okay, Jacob, you tell me what you were going to do.
Multiply the first one by 3 and the second one by 2.
Perfect. So you want to get rid of x. You can pick either variable, but there are some situations where you might have to multiply both lines. Again, whatever you want to do, on mine, I'm just going to recommend make one of those negative. So the coefficients would be opposite. I'm just going to put it on the bottom line. It doesn't matter though. So I'm going to run a 3 through the top. And just don't forget every single term, including the plain number on the other side, has to get multiplied by 3. So that keeps it the same equation. We're just manipulating it for our purposes to help us eliminate a variable. All right, so everybody in the top, I'm going to multiply by 3. So 6x, 12y, and then -12. Now on the bottom, I'm going to use a -2. So we're going to change signs here. -2 times 3x is -6x. -2 times 5y is -10y, and -2 times -3 turns into +6. Negative times a negative makes a positive. And the goal there is we're just eliminating x. If you wanted to go after y, you could do y also. It's totally up to you. So let's see. -10 plus 12 is going to give me 2. -12 plus 6 is going to give me -6. And y is going to end up being -3 there if I divide both sides by 2. Again, you can plug that in, either one in the original system or either of the ones that you created. If I create something, I usually go back up to the original system because the numbers are usually a little bit smaller, but it's totally up to you. Just don't forget to plug it in for the variable that you solved for. So we found y. So I'm going to plug that -3 in place of y. I just used the very first equation. So I've got 2x minus 12 equals -4. I'm going to add the 12 there. So you get 2x equals 8. And so divide by 2, x is going to be 4. So my intersection there, those two lines would run into each other on the graph at the point 4, -3. Okay, now this next one is pretty garbagey, right? I've got x minus y over 4 equals -1, and -x over 5 plus y over 15 equals 1/3. There is a question like this on the homework. Any idea how I might create a situation where I could do elimination here? What do you think? Okay. Would that get rid of the... I may want to try and get rid of the fraction there. So what if I multiplied the bottom by something to try to get rid of all the fractions? What would you maybe use? 5 would work, but you're still going to have a fraction. I'm going to recommend, let's do 15. Okay, then we'll just see where we're at. All right, now that first term, remember the 15 would go on the top, right? So I would, here, I'm going to write this out so you guys can see it. You'd have negative 15x over 5 plus 15y over 15 equals 15 times 1 over 3. All right, if I picked a number, get rid of my fractions, we should be good. This first one would just be negative 3x. This guy, the 15s would cancel, plus y, and then 15 divided by 3 is 5. All right, so that's really the second equation, but with no fractions. What about the first equation? What could I multiply that maybe by to get rid of the fractions? Hayden, what do you think?
4.
Just 4. Okay. So that first term would just be 4 times x, and then it'd be minus 4y over 4. Remember, don't multiply the denominator, and then 4 times negative 1 is negative 4. So really, that middle term will just be a minus y. I'm going to write that underneath here. So I have 4x minus y equals negative 4 as the other equation with no fractions. Okay, do I have to do anything else to eliminate? No. If you look at that, that has opposites on the y's right then and there. So we can just get rid of those fractions, and that was just nice for us. We don't have to do any more manipulation here. Negative 3x and 4x is positive 1x. 5 and a negative 4 is positive 1. Now, I would not, in this case, plug that back into one of the equations in the original system because you've got all those fractions. So if it was me, I would just pick one of the two that we created here. I'll just use the second one here real quick, it doesn't matter. So just plug in the variable that you solved for correctly. So we got x. So I have 4 times 1 minus y would be equal to negative 4. So we have 4 minus y, negative 4, subtract the 4. Okay, I get negative y equals negative 8. So if negative y is negative 8, I'm going to divide both sides by negative 1 there real quick. So positive y is positive 8. Your actual answer, if you had to write it as where the two lines intersect, was actually a nice number there. It's 1/8. Is anybody having a question? Okay. Now, remember, we've got two special cases if you're working with a linear system. You have, bless you, intersecting, which we had on the front. And then our two special cases, we have infinitely many solutions could be an option, or no solution could be an option. So if I'm looking at this equation here, we're just going to show you what this looks like algebraically. What would you maybe do to make a situation where we could eliminate a variable in that first system on the back there? What do you think? Okay, let me multiply by 2. I'm just going to write it right underneath the other equation. So I'd get negative 6x plus 10y. 2 times 6 is 12. All right, so that right away can eliminate the x. Now, the weird part here, this also eliminates the y because you have 6x and negative 6x adds up to 0. Negative 10y, positive 10y adds up to 0. So left on that side would be nothing, but 0 would be left over there. On the other side, I have 0 plus 12. All right, so all my variables have been eliminated actually. What do you guys think we should answer this question? Or how should we answer this question? This is no solution. If it's not true, if all your variables cancel out, not true, this is no solution. What it means, those two lines are parallel to each other if we had put them on a graph. No solution is the answer to the question, though. Okay, I'm going to do the kind of the same thing just to show you guys what this looks like on the second equation. I can multiply negative 2 by 2 to get negative 4, so let me just run a 2 through the top of this. So I'd get negative 4x plus 6y equals 26. Similar to the last question, the x's add up to 0, the y's add up to 0. It actually eliminates both. The difference here is I get negative 26 plus 26, which is 0. If you're doing elimination and you get this type of special case, you should always get 0 equals 0. What would my answer be here? Also, this all real numbers. This is true. I actually, to me, I know this is a stretch, but it kind of looks like an infinity symbol when I get the 0 equals 0. This is infinite solutions for this one. And if you're doing elimination, that's always what it'll look like. It'll be 0 equals 0 if you have infinite solutions. This just means these two equations were actually the same line. Is anybody having a question? Okay. Now, my favorite coin problems. Okay, this says Mike has a jar of coins in his kitchen, only dimes and quarters. All right, I'll just use the letter D for the dimes, and we'll use Q for quarters. He has 42 coins total. You're going to get a full equation from that. And it says the value of the coins is $6.45. Find the number of dimes and quarters in the jar. Who could? Just raise your hand and tell me. Could you set up an equation? Go ahead.
0.1 D plus 0.25 D equals 6.45.
Good.
Do you want me to do something?
Yeah, if you got it.
Just D plus D equals 40.
Perfect. All right, now, these always trip people up, but you've got one, like money goes with money. So the value of a dime is 10 cents. The value of a quarter is 25 cents. That goes with the $6.45. Absolutely nothing to do with the monetary value. Don't use those coefficients again. Literally, like, let's pretend you were blindfolded and I dumped out a jar of coins and told you to count the coins on the thing. Nothing to do with their monetary value, just 42 coins. The number of dimes plus the number of quarters would be 42. You're nothing to do with the money. Don't put the 0.25 and the 0.10 in front of that with the number of coins. Okay, now, the easiest thing to do, honestly, if you like substitution better, this would be really easy to get one of these variables alone in the second equation just by subtracting one. So if you prefer substitution, you could do that. I'm going to do elimination on this question just because that's what we're working on today. But in the situation, if we were taking a test or quiz or homework problem, if you'd want to use substitution instead, you could set yourself up for that pretty easily for this question as well. What I would just recommend here, and it doesn't matter which one you do, I would just run like a negative 0.10 through that bottom equation. And if you don't like dealing with decimals, you could clear that, but I'm not going to mess around with it and just save some time here. So I'm just going to copy that first equation real quick. Now, the second equation, I'm just going to put negative 0.10 in front of those first two terms. And then if you multiply 42 by negative 0.10, it's just negative 4.2, or just going to look like negative $4. I'm just putting that extra 0 in there to help me subtract with my place value there. So it's like 25 cents minus 10 cents here. This would be 0.15 in front of your quarters. Remember, we don't want to get a nasty number here because we're having a number of coins, so these should be nice answers. If I do like $6.45 minus $4.20, this would be $2.25. And then we're just going to divide, and that is a nice number, I'm pretty sure. Yes. So I've got 15 quarters. Now, it's completely up to you, but I would argue this one is way easier to plug this back into. So I know I've got 42 coins, so just do 42 minus 15. That should tell you the number of dimes. So your number of dimes should be 27. That would be super easy to check if you want to plug it back in and check your answer. Make sure it adds up to $6.45. Okay, now I have one more. This one does not have nice answers. This one has decimal answers, but don't think we're doing anything wrong. Okay, so it says, Hope went to the store. She bought 5 apples, 3 bananas for $6.50. Then it says Grace went to the same store. She bought 10 apples, 7 bananas, and she paid $13.75. Write and solve a system of equations to determine the cost for just 1 apple and 1 banana. Just somebody raise your hand. Who could set me up one of the equations here? Jacob, what do you think? Perfect. You want to do the other one? Excellent. So we're just using A for apple, B for banana. Okay, now, I'm looking at that. I can't eliminate anything right away. What might I do to create a situation where I could eliminate something? What do you want to do? All right. Let's do the top. Yep, because I can do multiply 5 by something to get 10. I would, again, I'm just going to recommend you do a negative just to make them opposite, so that way you can just add them together. This would be negative 10a. I'm just going to write it underneath here. Minus 6b. And then this would be negative 13. I'm just putting the decimal there to line it up like money so it's easier to subtract. All right, 7 minus 6 is just 1b. 1375 minus 13 is 75. So that means the bananas are 75 cents. All you have to do to find the apple is just plug that back in. You can use either equation. I'll just go ahead and use the first one. So 5 times my apples plus 3 times my 75-cent bananas would add up to 650. So I'm going to do 3 times 0.75 real quick. You get 5a plus this would be 2.25 equals 650. I'm going to subtract the 225 from 650. So I'm going to get 5a 425. Divide by 5 there. And apples are 85 cents. Is anybody having a question?